Welcome everybody. Today we start practicing some questions in topic 1, unit 1 of chemistry at Excel. So before we start, guys, I just need you to pause the video and read the first question carefully. The question says, how many moles of ions are in 40 cubic centimeter of a solution of 0.05 mole per cubic decimeter magnesium nitrate? So generally, since we are given the volume and we are given the concentration, you will start thinking about the first law that hits your mind, which is, concentration is equal to number of moles over volume. All right, so let's practice this first. Okay, so the concentration is 0.05 and the number of moles is missing and the volume is in a cubic centimeter. Just keep in mind, in order to unify the units of volume, the volume here has to be in a cubic decimeter. If you want to change it from cubic centimeter to cubic decimeter, we have to multiply by 10 to the power negative 3 or divide by 1000. So 40 here is divided by 1000, you will end up with 0.04 decimeter. So I have to take this value and just put it here. All right, you'll end up with 0.02. And for sure you're gonna choose A, but this solution is not complete. The question here is describing, or the answer here is describing the moles of MgNO3 by 2. The question is asking about the number of moles of ions. So you have to keep in mind, if we have MgNO3, and just keep in mind if it's in terms of ions, how many ions we have right here. We have Mg2 plus and 2 moles of NO3. So at that point, we have 3 moles per each MgNO3, and that's why you have to take this number, okay, and multiply by 3 because you have 3 ions. We have 2 ions of nitrate and 1 ion of magnesium. We'll end up with 0.006, and that's why your answer is C. Now let's jump to question 2. Pause the video and read the question carefully. Question says, NXO4 is an oxide of nitrogen. The percentage biomass of oxygen and this oxide is 69.57%. What is the relative molecular mass of this oxide? In order to determine the relative molecular mass of this oxide, we should know the number of nitrogen atoms. And since we don't know the number of nitrogen atoms, we cannot define or calculate the relative molecular mass. So how can I do this process? All right, so in order to write the percentage of oxygen, how can I do it in terms of law? So first of all, we have to say we have 4 oxygens. We multiply them by their atomic masses, and then you will divide them over how many nitrogens. We don't know, but we know the atomic mass of nitrogen, which is 14. So we can put 14x. Okay. And if you multiply this number by 100, you will end up with 69.57%. We are going to apply some math in here. So we have, like, if you multiply the whole thing right here, you'll end up with 64 hundredths. Okay, and if we apply some math, if we make a cross multiplying, you will end up with 400. Okay, and this one equal, you have to multiply, you know the math in here, you multiply this by this again and this one here, so you will end up with 4452.84 plus 973.98x. Okay, and if we just do some math right here, we have to say minus 4452.48, and the same thing is here, 52.84. You will have 1947.52 equals to 973.98. 8x, you divide it by the coefficient. Okay, it's just like a simple math. You don't need much thing. Okay, and you will end up with a value of x that equals to 2. All right, which means that the number of nitrogen is equal to 2. So the molecular formula is going to be N2O4. And if you calculate the molar mass of the whole compound, you have to say 2 times 14 plus 4 times 16, and you will end up with 92. So the 92 represents the relative molecular mass of this oxide, which is B. Okay, guys, let's jump to question 3. Pause the video and read it carefully. The question says, a sample of blood plasma contains 3.10 milligrams of sodium ions in 1 cubic centimeter. The concentration in mole per decimeter cubic of sodium ions in plasma is? Okay, so first of all, you have to think about, you have 3.1 milligrams in 1 cubic centimeter. I need to change this magnitude into mole per decimeter cubic. In other words, I need to change the milligrams of sodium into moles and the cubic centimeter into cubic decimeter. So the first step here, we're going to change the milligrams into grams, and then from grams into moles. So in order to change it from small value to big value, we have to divide by 1000. Okay, so you have to say 3.10 over 1000, and you will end up with 0.0031 gram of sodium ions. But we didn't finish. We have to change the grams into moles by dividing by the atomic mass of sodium, which is 23. You can get it from the periodic table. And if we apply this rule, you will end up with 1.347 times 10 to the power negative 4 mole of sodium. Okay, we didn't finish. We're done with the number of moles. Okay, so I can put them like 1.347 times 10 to the power negative 4. We're going to change the cubic centimeter into cubic decimeter. How can I do this process? Just keep in mind, we're moving from cubic centimeter to decimeter. We have to divide by 1000 in this case. So we can say, all right, we have 1 cubic centimeter. Okay, divided by 1000. So it's going to be 0.001 decimeter cubic. And so I can put this one here like this. And if you apply your calculations, you will end up with an answer of 1.35 times 10 to the power negative 1. And if you look at the answers, you can notice that the answer is A. Question 4 says, how many atoms are in 120 cubic centimeter of ammonia gas at room temperature and pressure? Since you're given a volume and it's at room temperature and pressure, we have to remember this beautiful relationship, which says each 1 mole of any gas at room temperature and pressure occupies a volume of 24,000 cubic centimeters or 24 cubic decimeter. All right, so my target in this process, I need to count the number of atoms. But if I need to count the number of atoms, I have to find the moles. And after finding the moles, we have to multiply them by Avogadro's number. But since we have only the ammonia thing, like it's about the molecule of an NH3, I have to do an extra step by multiplying by the number of atoms of ammonia. So let's simplify everything in here. We're going to calculate the moles of ammonia first in order to calculate how many molecules of ammonia we have, like the number. So we know the moles, we put X, and the volume that we have is 1 cubic centimeter. And if you apply cross multiplying, we were going to divide 1 20 over 24,000 cubic centimeter. And for sure, the moles are equal to 0.005 of NH3. All right. The next step is counting the number of NH3s. So we have to say 0.005. You multiply them by Avogadro's number, which is 6.0 times 10 to the power 23. If you stop at this process right here, you will end up with the number of NH3, like how many molecules of NH3. Okay. But the question, if you look at it, it says like we need the number of atoms in ammonia. So if we have NH3, we just want to count the number of atoms. We have 3 hydrogens and 1 nitrogen. So the total number of atoms is equal to 4. So you have to do an extra step by multiplying by 4, and you will end up with, if you do apply in your calculator, you'll end up with 1.2 times 10 to the power 22 atoms. Okay. All right. Now let's jump to the next one. Pause the video and read it carefully. We're going to calculate the empirical formula of this oxide. Okay, so first of all, we're going to say, okay, we have vanadium, we have oxygen, we have 15 grams of vanadium, we have 7.07 of oxygen, and in order to change their grams into moles, we divide them by their atomic masses. So it's 50.9 for vanadium, it's 16 for oxygen. You will end up with 0.295, and here you will end up with 0.44. We divide by the smallest number, which is vanadium, 0.295, 0.295, and you will end up with 1, 2, 1.5. You have to be aware of 1/2 in here. 1/2 actually refers to 3 over 2. Okay, we do not round it up to 2. So it's 3 over 2. So your ratio is going to be 1, 2, 3 over 2. And at that point, we don't, as we said, we don't round up. We have to multiply the whole thing by 2. So you'll end up with 2 to 3, which means that your compound has empirical formula of V2O3. And if you look at your answer, you can see that it's B. Okay, as we can see, since we're given the number of moles, we're given the temperature, the volume, and the question is asking about the pressure, the value of our constant is given, so it's definitely PV equals nRT. And since the question is asking about the pressure, I have to say, okay, the pressure is equal to nRT over V. We have 5 moles. The R value is 8.31. The temperature is in Kelvin, so we don't need to change anything. Okay, and you divide it over. The volume is in meter cubic, which is ready for applying, and you'll end up with 13,900 Pascal. So your answer is C. Okay, the question says here, what mass of anhydrous sodium carbonate is needed to make this volume of this concentration of this solution? All right, since we're given concentration and volume and the question is asking about mass, I have to calculate the moles and then change the moles into grams. So it's easy. You have to say C equals N over V. The concentration is equal to 0.08 and the volume is in cubic centimeter. So I have to divide the 50 over 1,000 in order to change it to cubic decimeter, and you'll end up with 0.05. Okay, so it's 0.05, and here this number here represents the number of moles of this compound, which is anhydrous. In order to change the moles into grams, you have to multiply them by the molar mass of the compound. So we have an A2CO3. How do I calculate it? First of all, it's 2 times 23 plus 12 plus 3 times 16, and then you multiply the whole thing by the number of moles, 0.004. So your answer is going to be 0.424 grams. Now we're going to jump to question 8. All right, so the question says the concentration of nitrogen dioxide sample is 0.5 part per million. What is the percentage of nitrogen dioxide molecules in the air sample? So as we said, we have to apply the rule of part per million, which is, we have 0.5 and it's equal to the volume of NO2 over the volume of air. You multiply it by 10 to the power 6. Okay. Now, the question is asking about the percentage of nitrogen, which means the question is asking you about to calculate the VNO2 over the V over air multiplied by 100. So the question is asking about this magnitude, but the only thing that you have is this. So how can I change this one to be like this? So first of all, we have to manipulate this section. In order to take this value alone, we have to multiply by 10 to the power reciprocal of 10 to the power 6 on both sides. Okay, so we cancel these guys. So you will end up with here, you have the volume of NO2 over volume of air. It's equal to 0.5 times 10 to the power negative 6. Okay, this is the magnitude that you have right here. We substitute it here and then we multiply it by 100. So what should I say? It's going to be 0.5 times 10 to the power negative 6, and then you multiply it by 100 in order to take it in terms of percentage. And if you apply this, you will end up with 0.00005%, which is